All right, here's your study guide for your trig exam. Step one is, can you do just the ratios, right? So, so on. So for cosine, circle the angle. The definition of cosine we need to know to begin with. So I'm looking for what side is adjacent and the hypotenuse. It's right there. So the answer is 20 over 24. You don't have to reduce it down. Number two, sine, circle the angle. What are we looking for? Well, the definition is opposite over hypotenuse. And again, if you want to, you can write down TOA to support the definitions of sine, cosine, and tangent. So sine is opposite over hypotenuse. Circle the angle. Opposite is 24, and the hypotenuse is 25. If I needed that missing side, I'd use the Pythagorean theorem. Cosecant. Speaking of that. So cosecant is the reciprocal of sine. So sine is opposite over hypotenuse. So the reciprocal of what I'm looking for is hypotenuse over opposite. So I already know the hypotenuse is 15, but I don't know the opposite side. So I need to solve for it. So to solve for it using the Pythagorean theorem, x squared plus 12 squared equals 15 squared. And then we're going to subtract and take the square root. So 15 squared subtract 12 squared gives me 81. And then the square root of 81 is 9. That's what the side I need. So the answer is 15 over 9. Tangent. Circle it. What's the definition? Tangent is opposite over adjacent. So opposite is 12. The adjacent side is 4 root 7. It's actually already there. To make it look a little prettier, you can multiply by root 7. 4 goes into 12 3 times, so the answer is going to be 3 root 7 over 7. This is for fun. This would be a great answer. Full credit. All right, what happens if you have a ratio and you have to find another ratio but no triangle? So we are going to draw a triangle. We're going to know that cosine, is adjacent over hypotenuse. We're going to label our own triangle. So the adjacent side is 15 and the hypotenuse is 17. And then from this triangle, we're going to find cotangent. So cotangent's the reciprocal of tangent. So instead of opposite over adjacent, we're looking for the reciprocal of that. Circle the angle. So the adjacent side is 15, but I don't know this side. So when I'm finding a missing side using the Pythagorean theorem, and I'm finding a leg, I'm going to subtract. It's going to be 17 squared, subtract 15 squared, and then you take the square root of that answer. So I'm just going to do that in one step. It's the square root of 17 squared, take away 15 squared. That's 8. And then you have your answer. All right, let's try again. I need a triangle. You know you should be doing it first. But here it is. Secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So this is the reciprocal, which is hypotenuse over adjacent. So the hypotenuse is 5 and the adjacent side is 4. Sine is opposite over hypotenuse. That's what I'm looking for. So I know the denominator is 5. I don't know this opposite side. So if I square and subtract, so 5 squared and 4 squared, 25 take away 16. That's 9. And the square root of 9, I can then get that missing side and it's done. Find cosecant if you're given secant. Kind of an ugly number, right? But secant, again, is hypotenuse over adjacent. I'm going to draw a triangle. And again, hypotenuse is 13 root 17. And the adjacent side is 51. And then I want to find this side for cosecant. So it is the square root of, and on your exam, I'm not going to give such numbers, but this is what you would type in. So I'm going to do that too. So let's see if I can type it in right. 13 and the square root of and then I'm going to square it. Subtract 51 squared. Let's see if it's a nice answer. Did I type it in right? So let me try again. See if we can make it work. Yeah. So it ends up being the square root of 272. I don't like this at all. I'm just going to go with it. So it's 13 and the square root of 17 over the square root of 272, and it's done. I'm not going to write it as a decimal. That's one thing I'm not going to do. So I'm not going to have a square root and a decimal in the same number. All right, these numbers are nicer. Draw a triangle. Oh, sorry, cosecant is hypotenuse over opposite. That's why those are the numbers. Cosine is adjacent over hypotenuse. So there's adjacent and the hypotenuse. I need to find this missing side for tangent because my goal is opposite over adjacent for tangent. So I know the denominator is root 5, but I don't know this side. So 5 squared is 25. Root 5 squared is 5. So it's 25, take away 5. So this is going to be the square root of 20. By the way, 20 divided by 5 is 4, and the square root of 4 is 2. So really, this answer is 2. Yeah, it fits. Perfect. Turn the page. On this page, we're practicing SOHCAHTOA to find missing angles or missing sides. So I want to find a missing angle. So circle the angle. This is opposite and hypotenuse. Which trig ratio uses opposite and hypotenuse? And if you need to, we can write this on top to remind ourselves. So it's the first one. And when we find a missing angle, we use inverse. And it's opposite over hypotenuse. Put the ratio inside it, and now use your calculator. Make sure your calculator is in degrees when you do it. So you want to go inverse sine 7 over 11. And it's about 39.5 degrees. Circle the angle. This is opposite again and hypotenuse. Same thing. It's inverse sine. And again, the ratio, which is 23 over 44, goes inside the ratio. So inverse sine 23 over 44. And you get 31.5 degrees. Again, opposite and adjacent. That's 61 over 27. That's tangent, right? So we're going to go inverse tangent, 61 over 27. And I get about 66.1. Last one like this, find a missing angle. You should try it first, right? So this is opposite and this is hypotenuse. So again, it's inverse sine. And it's 34 over 37. Try that again. That's 66.8. And it's done. Find the measure of each side indicated. So now I'm finding a missing side, not a missing angle. So to find this missing side, circle the angle and go, oh, that is adjacent and that is hypotenuse. So again, which one uses adjacent and hypotenuse? It's cosine. So we write down cosine of 68 is equal to adjacent over hypotenuse. Since the variable is in the denominator, we are dividing. So it's 16 divided by cosine 68, and that's it. If it was in the numerator, you'd be multiplying. And you get the answer 42.7. All right, circle the angle. That angle's here actually. That's a 90. This angle here goes with A. It's a little confusing, but that's the 90. This is A. So that's opposite in hypotenuse. So because of that, it's sine of that angle, which was what again? 71.4? 73? I'm going to call it 71. I can't see what it was. I'm going to say it's 71. Maybe it's 73. I can say it's 71.4. And then x over 5. Notice that the variable's in the numerator, so that means you're going to multiply these together to get the answer. So 5 times sine 71.4. I get 4.7. Let's try again. Circle the angle, opposite and adjacent. So which trig ratio? Press pause and think. What trig ratio? And then press play. So that's tangent of 39, and that's 7 over x. Notice x is in the denominator, so you're going to divide. So that means 7 divided by tangent 39. So 7 divided by tangent 39, and you get 8.6. All right, last one like this. Opposite and adjacent. So that's tangent 33 is equal to x over 11. Again, the variable's in the numerator, so we're going to multiply these together. So 11 times tangent 33. And you get 7.1. All right, what does it mean to solve a triangle? And what that means is you're going to find all the parts that are missing. So the parts that are missing, I'm going to label this one x, this one y, and there's b. So the easiest one to start with is b. So to find this missing angle, you just go 90 subtract 55.7. Try that again. 90 subtract 55.7. I get 34.3 degrees. There's a start. To find x, circle this. This is adjacent over hypotenuse, so cosine of 55.7 adjacent over hypotenuse. Because the variable's in the numerator, we are multiplying. So 4 times cosine 55.7. You get 2.2-ish, 2.3. Then for the last one, for y, this is opposite over hypotenuse. This one's going to be sine. So sine of 55.7 is equal to y over 4. So again, to get y by itself, you multiply. So that's what y equals. 4 times sine 55.7. So 4 times sine 55.7. And I get 3.3. All right, last one like this, I think, or is there a couple more on this side? No, that's it. All right, number 18, can you solve this triangle? So again, what are the parts that are missing? So the measure of angle A, I can do that quick. So the measure of angle A, I don't know the other angle, but I can do it using trigonometry. So A is opposite over hypotenuse. So opposite over hypotenuse. That's inverse sine, 3 over 9. So there's a good start. So inverse sine, 3 over 9. That's about 19.5. Then to find the other angle, I go 90 subtract 19.5. And that gives me the other angle by subtracting 90. That's 70.5. And then the last one, I can just use the Pythagorean theorem here. I don't need trigonometry for x there. And because I'm solving for a leg, it's the square root of 9 squared subtract 3 squared. So it's 81 take away 9. What is that? 82? I'm guessing here. 72. You could write it like this. You could write it like a decimal. What would this decimal look like? And you get 8.5. So these questions, you'd be able to use a calculator on, the first ones that we've been doing. So whatever you want, that part shouldn't stress you out. Now, when we're on this side, this is no calculator, and we need to figure it out. So find the exact value of these following trig functions. 19.6, 19 pi over 6. We haven't really talked about it when it's larger than the unit circle. I don't want you to get stressed out by that. So we're just going to call this one 11 pi over 6. There's another one like that. We're going to call this one 2 pi, just to keep it within the unit circle to make it easier. So how do I do that one, 11 pi over 6? The reference angle is 30. That is root 3 over 2 and 1/2. What quadrant is it in? 11 pi over 6. It's in quadrant number 4. So it's positive and negative, and then sine goes with the y coordinate. So the answer is -1/2. So I want you to practice these first. If there's another angle that's beyond the unit circle, no, all the rest look good, then I would change it. So just those two change. So cosine 3 pi over 2, not a reference angle. It's at the bottom. That's 0 and -1. Cosine goes with the x, so the answer is 0. Secant, oh, this one I should change. What's a good way? And I can change this one too. So let's change this to 4 pi over 3. That works. So if it's 4 pi over 3, still a 60, still 1/2 in root 3 over 2. 4 pi over 3 is in quadrant number 3. So that means both of these are negative. And secant flips the x coordinate. So secant goes with cosine, which is x. So you take the x and you do the reciprocal, and you get -2. 2 pi is on the unit circle. It's right here, and the point is 1, 0. Tangent is y over x, so it's 0 divided by 1, so the answer is 0. Pi over 6, right there in quadrant 1, so you can go right to the point. Root 3 over 2 and 1/2, quick. Cosine is the x coordinate, so the answer is root 3 over 2. So when it's in the first quadrant, the point should be real simple, and then the rule, and then the answer. 3 pi over 4 is in quadrant 2, and it's negative and positive. And sine goes with the y coordinate. So it's positive root 2 over 2. Again, you should really do it first. I know I'm going fast. For 7 pi over 4, it's in quadrant number 4. So it's a positive and a negative. It's a 45 degree. So it's root 2 over 2, root 2 over 2. One's positive, the other one's negative. Secant goes with cosine. And so the x coordinate you're going to flip. So if you do the reciprocal of this 2 over root 2 and simplify it, it's just root 2. 7 pi over 6, we're in quadrant number 3, so both are negative. It is 30 degree reference, there it is. Sine goes with the y coordinate, so the answer is -1/2. Again, you should be doing it first. 5 pi over 6, so I know the point is root 3 over 2. Wait a second, it's in quadrant number 2, so it's a negative and a positive. It's y over x. Just the numerators, y over x, so it's 1 over negative root 3. So when you multiply by root 3, you get the answer negative root 3 over 3. Again, quadrant number 2, so it's a negative and a positive. It's a 45. Secant, you look at the x coordinate and you do the reciprocal. Secant 5 pi over 4, it's negative 45. And then do the reciprocal of the x coordinate. Pi over 2 is on the unit circle on the axes. That's at 0 and 1. Cosecant is the y coordinate, and the reciprocal of 1 is 1. Sine at 5 pi over 3, so it's in quadrant number 4, so it's 1/2 and negative root 3 over 2. Sine is the y coordinate, so the answer is negative root 3 over 2. Cotangent pi, that's on the unit circle. Here on the left, that's -1 and 0. Cotangent is the reciprocal of tangent, so it's x over y. So the x over the y means this answer is undefined, because you can't divide by 0 on the bottom. All right. I am going to stop there. There is part 1. I'm proud of you for doing the work first, right? And getting support when you need it and studying as you're going on. I believe in you. You're going to do well on the exam if you study the study guide. All right, Mr. G Math, over and out. Till next time, part 2.